allowing communication between nodes without interfering with other nodes. However, tree networks are not as resilient as mesh networks, and a single point of failure in the hierarchy can affect multiple nodes. Hybrid topology. In a hybrid topology, two or more network topologies are combined to form a more complex network arrangement. Hybrid topologies are common in larger wireless networks, where different parts of the network require different topologies to meet specific requirements. For example, a wireless industrial control system might use a combination of mesh, star, and ring topologies to meet the specific demands of different parts of the system. One example of a hybrid wireless network is the LoRaWAN protocol, which combines mesh and star topologies. In a LoRaWAN network, end devices communicate with a centralized gateway via a star topology, while gateways use a mesh topology to communicate with each other and with a network server. In addition to understanding network topologies, it is also important to consider other factors when designing wireless networks. These include the range and coverage of the network, the frequency and bandwidth used, and the security and encryption implemented. The frequency and bandwidth used must also be optimized to avoid interference with nearby networks. Security is another important factor in wireless networks, as they are susceptible to eavesdropping and unauthorized access. Strong encryption algorithms and authentication methods must be implemented to ensure the confidentiality and integrity of data transmission. Furthermore, as wireless communication continues to evolve and expand into new applications, new network topologies are also being developed. One example of a specialized WSN topology is the cluster tree topology. In a cluster tree, sensor nodes are arranged in clusters, with each cluster having a cluster head node that forwards data to a gateway. The cluster head nodes themselves form a tree structure, with a root node that connects to the gateway. Cluster trees offer several advantages for WSN applications, including efficient use of energy, low latency, and simpler routing protocols. However, they also have some limitations, such as reduced network flexibility and the need for careful management of cluster size and location. Finally, it's worth noting that network topologies are not static but can change dynamically based on the needs of the network. For example, in a mesh network, nodes can join or leave the network, and the topology of the network will change accordingly. In some cases, dynamic network topologies can be used to optimize network performance and resilience. For example, in a disaster response scenario, a mesh network could be deployed with the ability to dynamically adjust its topology as nodes are added or removed from the network. The use of wireless communication continues to grow rapidly, with a wide range of applications in various fields. This growth has resulted in an increase in the number of wireless devices and networks, thereby necessitating the development and deployment of sophisticated wireless network topologies. These new wireless network topologies will be designed to provide ultra-low latency, high bandwidth, high reliability, and efficient utilization of available resources. Furthermore, artificial intelligence, AI, and machine learning will play a significant role in optimizing wireless network performance by analyzing data and making real-time decisions. As wireless communication technology advances and expands into new fields, the need for sophisticated network topologies becomes increasingly important. In some complex wireless networks, multiple topologies may be employed simultaneously to achieve specific requirements. Virtual reality in healthcare, advancements and uses. Virtual reality in healthcare, advancements and uses. Virtual reality, VR, is a technology that has been around for a while, but its applications in healthcare have only recently started to take off. The evolution of virtual reality. Virtual reality technology has come a long way since its inception in the mid-20th century. The first virtual reality device was the Sensorama, developed in 1962 by Morton Heilig, an American cinematographer and inventor. This device was designed to create an immersive experience for users, simulating the senses of smell, sight, sound, and touch. However, the bulky size and high cost made it impractical for widespread use. It was not until the 1990s that the technology started to gain traction, with the creation of the first consumer virtual reality devices, such as the Virtual Boy by Nintendo. However, these early devices were still limited in terms of features and capabilities. In recent years, advancements in technology have made virtual reality devices more cost-effective, compact, and versatile. Today, VR is used not only for entertainment purposes but also in fields such as education, engineering, and healthcare. Virtual reality in healthcare, how it works. Virtual reality in healthcare involves the use of VR headsets or other devices to create a simulated environment for patients and healthcare providers. This technology allows patients to experience a fully immersive and interactive environment, which can be used to help alleviate pain, reduce stress, and improve mental health outcomes. There are several ways in which virtual reality is being used in healthcare. For example, VR technology can be used to simulate surgical procedures or medical training, allowing medical students and doctors to practice procedures in a safe and controlled environment. This can help to improve patient outcomes during real procedures. Similarly, VR technology can be used to help patients with rehabilitation after an injury or stroke. For example, the patient may use VR to practice walking, reaching, or other movements as part of their rehabilitation program. This can help to improve motor function and reduce pain and discomfort during the recovery process. VR technology can also be used to help patients with mental health conditions, such as anxiety or PTSD. By providing a simulated environment, patients can be exposed to a controlled and safe environment, which can help to reduce stress and anxiety levels. VR can be used to simulate exposure therapy, where the patient is gradually exposed to the source of their anxiety in a controlled manner. This can help to desensitize them to the anxiety-provoking situation over time. Advancements in virtual reality in healthcare. One of the key advancements in virtual reality in healthcare is the creation of more sophisticated hardware and software. Today's VR devices are more compact, comfortable, and affordable than ever before, making them more accessible to healthcare providers and patients. Another important development has been in the creation of new applications and software platforms designed specifically for healthcare. For example, Proximie is a VR platform that allows doctors to perform surgeries remotely, while the patient is present in the operating room. This technology can help to improve access to healthcare in remote or underserved areas, allowing patients to receive expert care from anywhere in the world. Another example of VR in healthcare is the use of the Oculus Quest headset for virtual reality therapy. This headset uses a combination of audio and visual cues to help patients with anxiety, PTSD, or substance abuse disorders to overcome their fears and triggers.